All right, today is day 1 of factoring. We're about to get into a whole unit on this, and we're going to start with things that hopefully you are mildly familiar with. First up is trinomials, quadratic, ax squared plus bx plus c. I teach and use the x method. If you have another method that works for you, you are more than welcome to use that. I am not here to switch it up for you. I am just here to provide a technique if you are in need of one. So the way the x method works is you take your a and c values, you multiply them, and that's what goes in the top. Whatever your b value is goes in the bottom, and what you are looking for are two numbers that multiply to your product in the top and add to the number in the bottom. Once you have found those two values, your factors are x plus and x plus those two numbers. And the nice thing about factoring is you can check your work by distributing back out to make sure you get what you started with. So we're going to start when our a value is 1 for both of these. 1 and 10 gives us 10. B value is 7. So numbers that multiply to 10 and add to 7 are 5 and 2, which means my two factors are x plus 5 and x plus 2. Now, to make sure I had done this correctly, I could FOIL this back out, and I would get x squared plus 2x plus 5x plus 10, which combining those middle terms would give me 7x. And that does indeed match. So this is my factored trinomial. All right, just one more, because again, you've been doing this since Algebra 1. 1 times negative 28 is negative 28. Our b value is 3. Numbers that multiply to negative 28 and add to 3 are 7 and negative 4. I know one of them has to be positive and one has to be negative in order for the product to be negative. And because the sum is positive, that means the bigger number is going to be positive. So x plus 7 and x minus 4 are the two factors. If I were to FOIL this, I would get x squared minus 4x plus 7x minus 28. Combining those middle terms would give me 3x, and that matches what I started with. So this is the correct factorization. All right, well, what happens when a is not 1? The method is the same. Your steps are the same. We just have one extra step. Once we have found the two numbers that multiply and add to our top and bottom, we have to divide by whatever a is and clear any fractions. So jumping straight into an example, here a is 5, c is 20, 5 times 20 is 100, and our b value is 29. Numbers that multiply to 100 and add to 29 are 4 and 25. So everything we've done up to this point is the same. This is where the extra step is. I have to divide the 4 and the 25 by a, which is 5 in this case. Now 4 over 5 is going to be a fraction. I can't simplify it, but 5 over 5 is 5. So what I have at the start is x plus 5 and x plus 4/5. Now, I need to clear this fraction, and the way I do that is I multiply everything inside the x and the 4/5 by my denominator. In this case, that's 5. So this will become 5x plus 4. When you multiply a fraction by the denominator, all that's left is your numerator. And then we did not change the first parentheses. So if I wanted to be super sure I did this correctly and check my work, I could FOIL, and I would get 5x squared plus 4x plus 25x plus 20. Combining those middle terms, I would get exactly what I started with, which means where you have the cleared fraction is your correct factorization. Okay, moving on, 2 times 6 is 12. B is 13. Numbers that multiply to 12 and add to 13 are 1 and 12. For this polynomial, my a value is 2, so I have to divide both of those by 2. 1/2 will not simplify, but 12 over 2 does reduce to 6. So I have x plus 6 and x plus 1/2. This is where I need to clear that fraction. In this case, my denominator is 2, so I'll multiply the x by 2 and 1/2 by 2, which will just leave me 1. We did not change our first parentheses. Double checking my work, I get 2x squared plus x plus 12x plus 6. I can combine those middle terms, and it matches, which means this is our correct factorization. All right, 2 more just for good measure. 3 times negative 2 is negative 6. B is positive 1. Numbers that multiply to negative 6 and add to 1 are negative 2 and positive 3. Dividing both of those by 3. 3 over 3 becomes 1. Negative 2/3 can't simplify, but it is a fraction that I'm going to have to clear. My denominator here is 3, so multiplying both the x and the fraction will give me 3x minus 2. I did not change the first parentheses. Foiling this back out to check my work, I get 3x squared plus x minus 2, which matches. So I did indeed do this correctly. Okay, last one, 2 times 7 is 14, b is negative 9. So the numbers that multiply to positive 14 and add to negative 9 is going to be negative 7 and negative 2. They're both going to be negative. Dividing those by 2, this will not divide evenly, but negative 2 over 2 will. So we have x minus 1 and x minus 7 over 2, but I'm not done yet. I need to clear that fraction, and I'll do that by multiplying by my denominator, which is 2 again. Okay, let's FOIL to make sure we factored correctly. And it does match, so this is correct. Okay, that is trinomials. Hopefully none of that was brand new to you. What we're going to look at next might be a little different, and that is difference of two squares. If you have two perfect squares being subtracted to each other, you can factor that out, and I'm missing that parentheses there, as the square root of each term subtracted times the square root of 2 of each added. And the reason that when you FOIL this, you don't end up with a trinomial is because, let's say I get a squared plus a times b, then minus a times b minus b squared. What happens is my middle terms subtract to 0, and so all I'm left with is a squared minus b squared. So if you recognize that you have two perfect squares being subtracted, remember that's what difference means, you can factor it as such. So in order to recognize these, you're going to need to be familiar with perfect squares. So I would recommend memorizing up to about 16 squared. And to factor these, my suggestion is identify your a and your b terms. So if I have 25 minus 36x squared, the square root of 25 is 5, so that's going to be a. The square root of 36x squared is going to be 6x. So then to factor, I will do a minus b, 5 minus 6x, times a plus b, 5 plus 6x. And just like we did on the front, we could distribute FOIL to make sure that we have factored this correctly. And you want to make sure that your middle terms cancel and that you get what you started with. And that does match. So we are good. On the next one, I have 49x squared. The square root of that is going to be 7x. And then I have minus 64. The square root of that is 8. So I'm going to have 7x minus 8 times 7x plus 8. Again, if I were to FOIL, my middle term will cancel, and I will get what I started with. So I have done this correctly. I have 36a squared minus 25b squared. Square root of 36a squared is 6a. Square root of 25b squared is 5b. So 6a minus 5b times 6a plus 5b. Again, you could FOIL to make sure you did this correctly. Now I have 4x squared minus 121y squared. The square root of 4x squared is 2x. The square root of 121y squared is 11y. So this will be 2x minus 11y times 2x plus 11y. 2 more. Square root of 144y to the 4th is 12y squared. Square root of 121x squared is 11x. So that'll give us 12y squared minus 11x times 12y squared plus 11x. And then last but not least, these are two perfect squares. They look a little different, but the square root of 3x minus 1 squared is just going to be 3x minus 1. And the square root of x plus 6 squared is just going to be x plus 6. So a minus b times a plus b. We are going to need to do some operations here. This will be 3x minus 1. Distributing that negative here gives us negative x minus 6. And then over here, we're just distributing a positive, so it won't change the sign of anything, but I can combine like terms. So this first parentheses will become 2x minus 7, and my second parentheses will become 4x plus 5. Wah. Okay, that wraps up our day 1 of factoring. There is more to come.